G'day guys, I'm proud to announce Brian Noyes from the USA. In this session, he'll be talking about WPF, then he'll be diving into Prism, and then he'll talk about the differences between WPF and Silverlight. Should be a good session. So with that, I welcome Brian Noyes.
Okay, so part 2 here is basically Prism, as it's called for short, or Prism 2 to be more precise because it's the second release. The full name, Composite Application Guidance for WPF and Silverlight, is just too damn long to say. As I go through this, I'll warn you ahead of time. I am highly likely to sometimes say we and sometimes say they. The reason for that is from January to June of last year, basically the product lifecycle for Prism 1, I started out as an advisor to the team and became a part-time developer, basically working half-time for Microsoft as a vendor writing Prism 1. So basically if I say we, it's the parts that I like. If I say they, it's their fault. I didn't have anything to do with those parts. You know who I am. Basically we're going to quickly go over what is it at a high level. Then we'll talk about how does it modify your application architecture. Obviously it's for WPF or Silverlight apps. My demos tonight are all going to be WPF. I'll point out as we go what is different about Silverlight. But you know, if you know the basic architecture of WPF versus Silverlight, within the UI definition itself, the UI application, other than the host environment it's running in, and the fact that they are, in fact, separate libraries supporting it, the structure of a Silverlight app can be exactly like the structure of a WPF app. XAML-based, code behind, supporting code behind the scenes, same binding mechanisms, or mostly the same binding mechanisms, things like that. So basically everything in Prism, pretty much the entire focus of Prism 2 was to take what we did in Prism 1, which was purely WPF, and put the and Silverlight on there. There's almost nothing new in Prism 2 for WPF other than some changed namespaces and basically one new feature in terms of the way you plug views into your UI application. So my demos again will be WPF. Yeah, Adam.
I think you'll find that there's, we're running a few projects and some other companies are running a few projects with Silverlight and Prism at the moment.
Oh, okay, great. Yeah, I mean, it's definitely being used. I'm just saying that my demos are all set for WPF, and that's where I spend most of my time, so I'll stay there so I don't embarrass myself in Silverlight. Okay, and then once we get past the architecture and the way it kind of modifies the way you structure things inside the bubble of your UI application, we'll break down the 4 main features of Prism itself in terms of shipping code that you can reuse. And that's regions, which is a UI composition, sort of similar to master pages in ASP.NET, where you kind of define placeholders and plug content into those placeholders. Modules is basically a plugin model for your UI application to load up the chunks of functionality that you want to populate the application. Commands are like WPF commands, or how many people in here did MFC? I'm really dating myself. MFC had commands. Gang of 4 documented commands decades ago. They kind of went away for a while in Windows Forms, and now they're back in WPF. And then we're going to skip another generation because Silverlight actually has no commands. So how does Silverlight get this feature? We'll talk about it when we get to that part. And then events, basically this is a pub-sub model, pub-sub pattern, in-process pub-sub to let loosely coupled parts of the application talk to one another through events. So we'll talk through each one of those. If we have time at the end, we'll talk quickly about some of the underlying patterns that are there, but we'll hit on a lot of that as we go. Going to be kind of a fast and furious pace here because it's there's a lot of stuff in Prism and hours not that much to cover it. What is it? Who created it? Patterns and practices, you probably heard of them. Enterprise library, some of the application blocks and things. This is just another thing that they put together to try and say, here's the best way to build a particular kind of .NET application. It does have shipping code, but they can't call it a product because they're not a product team. So it is a set of guidance if you ask a patterns and practices guy. To us, it's a bunch of stuff we can download and build our apps faster with it. How many people in here did CAB, Composite Application Block, or Composite UI Application Block? I pity you fools. Actually, I did a fair amount of CAB myself. This is kind of a successor to CAB. CAB was a set of libraries and stuff for Windows Forms to do composites, basically, in that space. But it was something that was very all-pervasive within your application. You pretty much had to start from line 1 of code in your Windows Forms app as a CAB app, and everywhere you looked, you knew it was a CAB app. One of our design goals with Prism was to not do that again, to make it so it's more kind of an a la carte menu of features that you can go in and say, I just want pub/sub events. I don't care about all the rest of that junk. Just give me a non-invasive way to use pub/sub events, or just use regions, or just use commands. And from what we found and the feedback from the community, we did pull that off. So we didn't start with the cab code and port it. That would have been a mistake. Anyone who's done Windows Forms and WPF and done WPF correctly knows that it's a completely different world, completely different way of building UI applications. So we didn't want to just try to port what was there. We wouldn't have really benefited by doing that, especially because the existing cab code does support WPF to a very limited degree in a very Windows Forms-y kind of way. Oh, that was out in the hallway. So what actually ships with Prism? The things that will be most important to you is the first line, collectively called CAL, Composite Application Libraries. It's 3 libraries for desktop, meaning WPF, and 3 libraries for Silverlight that provide the reusable chunk of code that comes along with Prism that you build on top of. It also comes with a what's called a reference implementation, fancy terminology for a big sample app. It's a sample app that has a full business context of stock trading, is somewhat representative of a real app in terms of the complexity of the number of views coming together and switching of views and that kind of thing, but not so complex that the Prism parts of it get lost in the business logic. And then, of course, there's quick starts that narrow in on each individual feature, showing you how to use those in isolation without a lot of surrounding business context. Obviously, documentation, how-tos, ignore the publish spikes. One of these days, I'm going to remember to remove that. We used to have some of our kind of prototype experimental code that we were using in development, put that out on Codeplex, and that got yanked down a while ago. So the current version, if you go download it, it'll be labeled February 2009. That's Prism 2, basically, is the current version. They are working on another version. Main thrust of that, it's not a lot of new functionality, but it's just to bring it up to date with Silverlight 3. The current shipping version out of the box does not work with Silverlight 3. There are some kind of advanced blog post things where people have modified the code themselves, because for the composite application libraries here, you get full source code with the MSPL, the permissive license that basically says, take it, use it, modify it all you want, just don't expect to submit it back and have us add it to our code base. Why do you do this stuff? The whole idea is separation of concerns, loose coupling, testability, maintainability, all the ilities basically, is trying to not do the old style application of one big window with thousands of lines of code and your code behind for the window, hard to maintain, hard to test, and so on. So basically it's taking that complex UI application, slicing and dicing it into lots of little granular parts that are easy to test, have a well-defined, focused purpose, separate abstractions for different kinds of code within your application, that kind of thing. We're talking about the Lego building block approach to building a UI application, not just the monolithic style. Obviously, you could do some of that just by breaking things up into user controls, but if you go with a user control-based approach, what you typically end up with, if you picture your main window there and you start slicing and dicing and go, this is user control, this is user control, boom, 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 these are all user control. So I'm being very granular, encapsulating the code and the code behind of the user control. Where you still end up with tight coupling is that this part has to talk to this part to some degree, and this one to this one, and this one to this one, and this one to this one. And you get all this cross-coupling, communication paths, object references, assembly references to the places where those are defined. So even though it is kind of sliced and diced and more modular by definition, just using user controls, it's still tightly coupled at runtime and tightly coupled at design time. It's harder to just slice out a whole chunk of functionality and not ship it or replace it with a new implementation. So composites are an alternative way to kind of slice and dice it that is more loosely coupled so you don't get stuck in that scenario. How do you modify your architecture in the WPF app? Basically, there are some well-defined abstractions that we usually call out. Not all of these are required. The first one is kind of the hardest one about giving a 1-hour talk on Prism. How many people in here are completely comfortable with inversion of control and dependency injection containers? Okay, look at the number of hands. That's somewhat of prerequisite knowledge for using Prism, because the same motivations that make you want to slice and dice and build your UI application out as a composite app are the same motivations of why people use IOC containers. It's loose coupling, composing things dynamically at runtime, and all those same motivations are why containers are becoming very popular. So under the covers of Prism, there is a container. By default, it's the Unity container that's also written by patterns and practices. It's completely swappable with container of your choice. So if you want Spring.NET, Structure Map, Castle Windsor, and Inject, there's lots of those out there in the .NET space now as it's becoming more popular. You can substitute those in. Basically all the Prism code in those libraries just work against a facade interface. You want to swap in your own container, you just implement the facade interface. It's like 8 methods, it's not that hard. They're usually a one-to-one map with some method on your container. But in using Prism, as we get into the demos, you'll see places where the magic is happening. The magic is the dependency injection, and it provides some of the loose coupling that you get in building applications this way. Bootstrapper, every application has some startup code, and when you start building things as composites, as you see the demos here, a consistent initial impression of Prism is, why the hell would I go to all that complexity to build a simple little application? Well, if it really is a simple little application, the answer is you wouldn't. Okay, but you got to demo something that's understandable in a short period of time. So really, what is the space that this is built for? Think about rebuilding Outlook from scratch. How many different views or screens or chunks of screen real estate are there in Outlook as discrete views that you have to build, put all the supporting code behind or logic for, and bring them together and dynamically swap them out and so on. At least dozens, maybe hundreds in some applications out there. That's the space this is really positioned for. If you're building your admin utility number 27, you're probably not going to bother with Prism. 3 or 4 screens, even a dozen screens, probably not worth the extra upfront complexity that you pay by setting up the infrastructure to build it in a composite way. But if it is a big complex app like that, it's usually more than show main window as your initialization. You got to go out, pre-populate some resources. If you're doing containers under the covers, you got to create the container. You got to register some types with it. You got to set up some other stuff that the rest of the application is going to require. And specific to Prism, there's a defined workflow we'll look at. So a Bootstrapper is just a centralization of all your initialization code for the application. You could just put that in your code behind for the application class. Separating it out into a Bootstrapper just makes it more testable as an isolated thing that's not tied into the specific UI context. Shell, that's just a fancy word for your main window, but it does have a particular connotation, which is, if you think about expression, how many people have at least looked at Expression Blend? Probably most of you. Okay, how many have looked at one of the other expression products? Okay, probably most of you. They look a whole lot alike, right? There is one main application for Expression Blend, Expression Encoder, Expression Web, and Expression, whatever that other one is, Design. They built a shell, and they dynamically plug parts into it. Expression as a whole was the first WPF composite application. In fact, we talked constantly to the Expression team as we were developing Prism to kind of suck knowledge out of them about, what were the patterns you used, how did you implement those in WPF, because they kind of, had to blaze the trail themselves of what's the best way to do this stuff with WPF. So this is, for that kind of application, a shell is basically a place for content to live. And it provides a consistent look and feel to the content that gets plugged in, but it doesn't provide much else. It should be generally stupid about the business context of the application. Modules, that's where the real functionality comes from. So these are discrete chunks of functionality that plug into your application, standard plug-in pattern kind of thing, get dynamically loaded up, cite their content into the shell, and then have the supporting code behind to support those views, as they're called. Next one there, views, just an abstraction for the chunks of real estate, screen real estate that you plug into your app. Typically a user control, but there's a few other things you can use there we'll talk about as well. And then services are the abstract notion of services, not WCF services or web services. This is just a chunk of reusable code locatable through the service locator pattern, which is typically satisfied by the container itself. Just a way to reach out, have some central logic decoupled from the rest of the application that you can get to do things like data access, authentication, things like that. Quick, summary of dependency injection and IOC here, since you will see some code about it. They are separate patterns. You could do whole talks on those on their own. At a simplistic level, all you're doing is you're saying, instead of me calling nuon objects to create them and having to figure out if they have a parameterized constructor, where do I get all those parameters from and how do I populate those with their dependencies and so on, you delegate construction responsibility to the container. So instead of saying new my object, you say container, give me a my object. And the container is up to figuring out how does it go about constructing one of those. Does it just call the default constructor, or does it have to create, in this case, if it's a customer, does it have to first find or create a logger and plug the logger into the customer so it can give you back a customer reference? So the IOC part is really the construction of the object. The plugging in of the logging component so it can construct the object is the dependency injection part. Standard patterns that are out there, well documented. A container, most containers out there, I have yet to see a real container that doesn't do both. It's an IOC and a DI container, and people usually pick their favorite term. Some religiously call it an IOC container, some religiously call it a DI container. It's usually both. It does both responsibilities. And we'll see how that manifests itself in the sample code here shortly. Just what do they look like under the covers from an API perspective? The two main things you care about, this one is based on Unity, but Spring.NET, Castle Windsor, they all have similar methods, maybe slightly different names. Register basically tells the container, you are responsible for constructing this type. And it's typically in the form of people are going to ask for an iLogger when they give them the log4net implementation of iLogger, or give them the logging application block implementation of iLogger. So in this space, you also typically do a lot of interface-based design, separation of implementation from interface, so that you can mock those objects out for unit testing, or just substitute in whole new implementations. Resolve is basically your equivalent to new. So you walk up to the container and say, resolve iLogger. And it gives you back a reference to iLogger. You don't care what the concrete type is, you just program to the API. And that lets the container do something like in my production code, I get the production log4net iLogger. In my unit test code, I get a stub that was generated by my mocking framework that happens to implement iLogger dynamically. Lots of other things you can do here. Build up, you can create the object yourself, pre-populate it with some state, hand it over to the container and say, when they ask for these, give them this one. And configure lets you do it declaratively. Go out to your config file and say, for iLogger, it's log4net, for this, it's this. And you just declaratively do your mappings out in your log file, or in your config file. So that's a very quick elevator pitch on how to do DI and construction with Unity. Bootstrapper already described this, just a central point for initialization of your application. If it is a Prism app, there is a defined workflow you have to go through in there. Most of this is pre-built for you in the Prism code itself. So specifically, you have to set up the container, register some types with it that are Prism types at least, and possibly some of your own types. You have to set up the region mappings. Again, Prism code, all encapsulated. Mostly you don't worry about that unless you write some MySuperFragilistic container component that you want to make a region, and then you have to set up your own region mappings for it. Create the shell, which usually means window1 equals new window, window1.show. But basically it delegates that to you because it doesn't know what does it mean to create the shell to you. Had a customer over in Norway building this complex app for managing oil platforms and container ships and things like that. They had a standard setup that it was an operator workstation with 3 screens. So their Prism app was basically their shell was fire up 3 windows, position them on the 3 monitors. And so the Prism code basically through a abstract method hands that back over to your code to say, you create the shell and show it whatever that means to you. Initialize the module. It's usually modules, multiple. That is basically load up the real functionality of your app and plug it into the shell. So that workflow is pretty much going to happen in every single Prism app. And mostly it's already encapsulated for you in the base class. Yes, sir?
How does that the modules relate to MEF?
Great question. So the question is, how do the modules relate to MEF? You could make a direct one-for-one. Well, for one thing, at a simplistic level, how do the modules relate to MEF? Our product planner on Prism is now referred to as the MEF dealer. He's the program manager of the Managed Extensibility Framework. So a lot of the knowledge that went into the way we did modularity carried directly over to the MEF team and went into their thinking about how do they load up things, how do they declare them, and so on. Now MEF is much more general purpose, much more kind of loosely coupled. If people aren't familiar with MEF, I mentioned it earlier, it's the extensibility model for Visual Studio and or your application if you want to support extensibility. Lots of analogies between modules in Prism and MEF parts, as they call them, that are basically things that load up at runtime. You can identify those programmatically or through configuration. They load up, they can kind of in a loosely coupled way take dependencies on each other and communicate with each other. So there's a lot of things where you could just choose to do it as Prism. You could choose to do it as MEF. You could even choose to just do it based on a DI container. So I did a blog post a couple months ago that Glenn ended up linking back to that just showed a simple plugin pattern using Unity. So depends on the complexity of what you're trying to do. MEF is really, its primary purpose, first and foremost, is to plug in extensible parts to an application, including Visual Studio as an application. Under the covers, how does it do that? It's basically got a DI container. It's not a general purpose DI container. That's not its first and foremost job. Could you use it as one? Yeah, as long as you kind of dig under the covers and see what their APIs are. But that wasn't really what they're intending to build. If you want a general purpose DI container, at the current time, you probably go with Unity from a Microsoft perspective or one of those open source ones that are more general purpose. But a lot of these things have overlapping goals and overlapping patterns in terms of the way your code evolves to do those things. I'll talk a little bit more about what constitutes a module shortly here. Shell, I think I already said most of this. It is just the place that your content lives. Should be pretty much stupid of the business context of the app to the extent possible. And manifest itself is just a WPF window or a Silverlight user control, basically, that you plug in as your top-level view. Views, again, just an abstraction of a chunk of real estate. Like I said, typically it is a user control in WPF and in Silverlight that you can plug into a parent element as a chunk of screen. But keep in mind, in both Silverlight and WPF, we have this nice composition story between data templates and data objects, where you can have this loosely coupled definition that I've got something like a customer object, and for one of the parts of my app, I have maybe a grid presentation of customers, and for another part of my app, I have a details one, and maybe I have a different kind of summary view based on a custom control somewhere. And so you can basically bring together a custom visual tree that's defined in the data template and marry it up with a data object through data binding and just say, when you have a customer object, render it out this way. So basically the data template itself becomes the view definition. Even though it has no supporting logic, it's just purely declarative XAML. You can hook up supporting logic through separated UI patterns such as view model we'll see in the demos here shortly. So this just shows that reference implementation, RI as they call it, the stock trader. And the red borders here are just kind of highlighting this is what we mean by view. Slice and dice pieces of your application that are kind of isolated on their own from a UI definition perspective, and that can be a view definition on its own. Services I already talked about is just an abstraction of some reusable code. You can locate, reach out, and get, typically through the container, make calls against to get some functionality or get some data. And there are a number of these that are built in by Cal to provide some of its features. The logging one here, all it really does is trace.writeLine. Not a very impressive implementation, but it's more just to show the pattern of using those. Region Manager, that's the thing that you use to plug your views into the shell, basically, to locate the available pieces of real estate, the content placeholders in ASP.NET terms, and to plug in your content. Event Aggregator, that is the hub, basically, of your pub-sub events model, and so that's plugged in as a service as well. And then the module catalog is the thing you use to identify what modules do you want to load up as the plugins for your application. So those are all kind of pre-built ones that are part of Cal. And then typically you're going to write one-to-many of your own services, which are first and foremost, any of the data feeds into your applications are usually encapsulated as services. You might have an authentication module. You might have something like a caching module to share some cache data across the application. Things like that you would write as a custom service. And all a custom service is really typically is a class that implements an interface that you locate through the container. Okay, Cal features, stepping through these one at a time. What's a module? Just a chunk of functionality. How do you determine what goes in one module versus another? Completely up to you. What are some of the design criteria you might use for that? you have to think about your feature set is one thing. One way to slice and dice things, basically, if the nature of your app is you have several distinct feature sets, and you might ship different versions of your app. You know, there's like a Visual Studio with a Pro, Premium, and Ultimate version, and there are different sets of functionality supporting those. Those give you clean lines of separation to say at least those that I want only in the Pro versus the Premium, I want to have those separated out so I can not include those in the the less advanced version. So that's one thing you can kind of look at in your design analysis of your use cases to say, these are in one module, these are in another module. They do have to be pretty much separate and distinct. There can be some cross-communication because of the loosely coupled communication models we have, but they have to be kind of self-contained sets of functionality. Another line of separation is how are you going to dole out the work? If you've got 5 people on your team, you want them to work mostly independently from one another. Decide ahead of time which pieces of functionality you're going to give to one versus the other, and each of those becomes a module. Now you reduce your source code contention. Each guy can check out his module and leave it checked out all day long, and not disturb the other people. And the individual modules should be loosely coupled from one another, so they don't have to spend all day talking to one another to get the work done. They can just work in isolation and talk just about the points of loosely coupled communications, agree on contracts there basically of how they're going to do that. So multiple ways you can decide to slice and dice it, totally up to you, but ultimately it manifests itself as separate assemblies that don't know anything about each other ideally. There may be some lifetime coupling between them. You know, if one has to start up because it's going to be a source of events for another one, you can provide some indications to the module loader to say, load this one first and then load this one. But you want to avoid type coupling between the modules, kind of like you do with designing services in a service-oriented world. The things you do inside of a module, first and foremost, is create views and plug them into the UI. And obviously those views have to have some supporting logic behind them. So you'll probably be doing something like the view model pattern. You have view models supporting the views. There may be application controllers that span multiple views and decide which ones to show at a time. So all those things can be the different kinds of types that are within your modules. And we'll see examples of those here shortly. I got to cover at least what modules are and what regions are before we can finally get to a demo. Regions, I already talked about high level. Think of them, how many people have exposure to ASP.NET? Hopefully most of you. Master pages, content placeholder. You know, the concept there is the master page is the shell. It identifies portions of screen real estate where content can be plugged in, and then the content gets plugged in dynamically into those placeholders. Same basic idea here. Regions are the content placeholders within your shell, and then the modules load up and plug content into those. Okay, visually kind of looks like that. So, and behind the scenes we already said there's a region manager that supports it. So let's finally get to some demos that make this more concrete. If we had more time, I'd do all this before your eyes to see it come together, but for time savings here, so I don't finger fumble too much, we'll just use some pre-canned demos here. This one is kind of the simplest possible Prism app you could have, where you at least have some functionality broken out into a module. It's not impressive functionality, it's a button on a form, but at least you'll see what the overall architecture is here. You have to have a root application. So whether it's Silverlight with the Silverlight app or WPF with the WPF app, you have some kind of app, add new project WPF application. Has the standard structure of one of those apps with an app.xaml representing the application class, window.xaml, which is typically going to be your shell window that you're going to set up as the top level look and feel and navigation for your application. Then you have this thing we call the Bootstrapper. That's where you want to factor out all your startup code too. And it's not much that you need for a Prism app, but it's a one-stop shopping. Where do I go to find all the initialization? Just go to your Bootstrapper. Now in a standard WPF app, you would look in your app.xaml and you would see a startup URI equals window1.xaml in this case. In a Prism app, typically you strip that out because that's initialization code. You want that all over in your Bootstrapper. And more specifically, there's a defined place in the startup workflow of a Prism app where you want to do that at the point where the Prism base classes says, now it's time to create the shell. So you strip out the startup URI that's here by default when you create the project, and you drop to the code behind typically, override the end startup event, and just hand off to the Bootstrapper to say, do initialization, basically. The base class that we'll look at has the run method. It implements that workflow we saw in the slide. You just have to provide some hook points for the things that it doesn't know about. And that comes in the form of overloads from a base class called Unity Bootstrapper. Obviously, if you go to a different container, you'll have to write your own base class. You pretty much take the source code for the Unity Bootstrapper and find and replace Unity with your dependency injection container. There are specific places where it constructs the container and then resolves types through it and registers types. You just have to do the corresponding thing for your container. But if you're willing to use Unity as your container for your app, it's already pre-built for you. And like I said, in that workflow, there's one point where it says, okay, now's the time to create the shell and show it. They just have an abstract method. You override that method and you do what's appropriate to create your shell, show it. And then the one extra step is you have to return it to the base class. The reason for that is the base class is doing some WPF magic under the covers. If you've heard of things called attached properties, there's this thing called the attached property trick where you can basically hook in some behavior from the UI based on just setting a property in the UI. So we're basically using the attached property trick to hook in the region manager so it's accessible throughout the UI to the views that get plugged into that UI. At a high level, that's why you return it there. And you return it as a dependency object because that's the thing that defines the API for setting and getting attached properties or dependency properties in general. The other one, this is a they thing. They should have created this as an abstract method as well. They did not. They created it as a concrete method that will not work if you just call the base class one. So you always have to override it and return at a minimum this part, a new module catalog. Okay, once you have a module to load, the API is you just say .add module with a type, .add module with a type. It's one of these things people are calling these days a fluent API. So you can just keep saying add module in the chain, or do various other operations in a somewhat sentence-like structure. In this case, we're instructing it to load module 1, and we'll get to what that looks like in a moment. But that's basically all there is to the Bootstrapper. The only other trace of Prism in the root application here is that we have to identify our regions the content's going to plug into in the shell. Shell is supposed to be stupid about that content. So basically what we do here, we've got a root child element here of grid, which resizes its children to fill the client area. And the child element of that, we actually use a content control directly. If you're familiar with some of the base classes of WPF and Silverlight, there's content controls, there's item controls, are the two main base types for most of your containers. Itself, usually you use a derived type in real applications such as button and label are derived from content control, and you plug some content into those. In this case, we're just trying to define a chunk of real estate that we can plug content into ourselves. So we don't need any separate behavior or adornment to this thing. The content control itself works great for just defining that content placeholder, if you will, in ASP.NET terms. We do have to give it a name so it can be addressed. So this is one point where you have some basically implicit coupling between the shell and the modules that load up. Yes, sir?
Does this fit in at all with the navigation framework in both WPF and Silverlight, or is it really just implementing it itself?
Good question. Does it fit in with the navigation framework? I assume you're referring to the navigation window and page structure?
In WPF and navigation framework.
Right. There's no direct relation. Other than within a given portion of your shell, you could plug in a navigation window, or not a navigation window because that's got to be the top part, but you could use the navigation framework to have some content such as a wizard or something like that. You could have a pop-up window that has a single region in it and plugs its pages into there and uses the navigation service to do that. So you can provide your content in the form of the navigation mechanisms of WPF and Silverlight, but there's no direct relationship here other than also your top level window could be a navigation window. At that point, your content, actually I haven't thought that one through. I'm not sure exactly how I would structure that if the top level window was navigation window.
Yeah, I was interested, is it a one or the other sort of choice you make?
In terms of the top level window, I think it would be a one or the other kind of selection there. So this is more for, kind of the traditional picture of a Prism or Composite application is a paned type of top-level window where you have defined panes that contain a certain kind of content. Traditional Outlook app, navigation on the left, a main content pane, maybe dividable vertically, and you have this notion of there are certain kinds of content you expect to show up in a certain kind of place. Like I worked on one a few weeks ago with a customer in South Dakota that it was for field reps out in the field to fill in time cards, look at their work orders, that kind of thing. And so they defined a region that for every different kind of data object basically that they had wizards that they would go through to fill in the data for that. So they had a region that was defined, all the wizards showed up in one place, even though they were lots of different wizards. And for that wizard navigation, they did use the navigation service for swapping out the views. Okay, so here in the shell, we just leverage the content control as a thing we can plug content into and identify it as a region. And like I was starting to say, this becomes a point of coupling, basically a contract between whoever develops the shell and whoever's developing the modules that you would have, in your design document. We have a main content region, we have a left navigation region, we have a wizard region. Whatever regions you define at the shell level, you sort of publish those to the module developers so they know where they're allowed to poke their views in, basically, and what the intended purpose of that location is within the overall navigation scheme of the app. In this case, the content control, who's going to provide the content, really Prism is going to plug that in as you add views to the regions. So basically from a module developer's perspective, you go to the region manager, you say, give me the main content region in this case, add my view to that region. Programmatically, that's what you do. And that's basically what's going on over here in the module. Let's look at that code real quick. A module ultimately is just a class. And so theoretically, you could have multiple modules in a single assembly. We recommend you just have the assembly kind of represent the module, because that's how we're used to thinking of assemblies. A module is a container for functionality, just like an assembly is. But from a pure implementation perspective, it's just a class that implements an interface defined by Prism called iModule. And the only thing on iModule is initialize. So think of this as the bootstrapping for your module. Bootstrapper is for the application as a whole, get everything spun up and running. Initialize on each module is the bootstrapper for that module. Create the views, plug them into the right place, create some controllers, spin worker threads, set up services, whatever functionality that module is contributing, this is the place to set it up and get it running as it dynamically loads at application startup. In terms of module loading, slides talk about this, but I won't bother. Let's switch back real quick. Module loading, we have several forms. I probably skipped over it there. Where's our modules? Modules, modules, modules. There. So the forms that we support are basically 4. Statically is what I was doing there, where you know when you ship, this version of the app is going to have module A, B, and C plugged in. You break them up for separation of concerns, development purposes, loosely coupling for testability, things like that. But you're going to ship with a certain set of features. If you're going to more dynamically compose the features at runtime, you've got a couple of choices. One can be a thing that a lot of plugin models do, like Winamp, I know used to do this. CodeRush, which I use in Visual Studio, does this. So you can just drop DLLs in the directory. At startup, they'll scan that directory, locate the plugins, and load them up. So the module feature supports that as well. And you can declaratively do it in config and say, for this version of installed version of my app, I have module A, B, and C. For that one, I have D also. We also support on demand. So basically, if you have some not often used feature that you don't want to load up and consume memory on, maybe it loads up 2 gigabytes of data for some administrative function you do once a month. You don't want to load that at runtime, which is the default, or at startup time, which is the default for all the rest of these mechanisms. So there is an on-demand loading mechanism as well. So back to our demo then. This module, class, just a class, implements that interface. And all it's going to do as it starts up is set up the view that it wants to present in the shell. That's just a user control over here that has a single button in it so we can see when it loads up. Okay, nothing fancy here. Not even any functionality behind it for this demo. We go out to this thing called the region manager. So this is the first place where the DI, the container, injects itself in your face. How do we get to the region manager? That thing is a singleton service contributed by Prism over in our Bootstrapper. Far away, the module is not supposed to take direct dependencies on the shell. So how do you get to the one object reference for that singleton instance? Well, if you really hate containers and don't want to learn about them, you could actually write some code to do a standard singleton pattern in .NET, have a class with a singleton property, .current, .instance, .whatever, and have a static instance of that thing under the covers. But Prism by default tries to leverage the full capabilities of the container. So the container way of doing this is you just say, in order to construct a module 1, you need a reference to an iRegion manager. You don't know where that comes from. You don't know what the concrete type is. Whoever constructs you has to figure out how to come up with that. And who's going to construct module 1? Well, it's being loaded by Prism. Prism's aware of the container. It does all of its construction through the container. So basically, as the container says, I need to construct this thing, how do I do that? I got to call this constructor. I need one of these to do that. Basically, the container looks back in itself and says, what do I know about iRegion Manager? Oh, someone already registered one of these as a singleton. I can just give them the reference to that singleton. So automatically, a reference to an iRegion Manager appears in your object as it gets constructed. That's the core notion of DI, is that as an object is constructed, you delegate that construction responsibility to the container, and it can take care of constructing and or locating the objects that it needs to inject in your object so that your dependencies are populated. So basically this comes into us because it was put into the container by Prism. We hold on to it till the point where we need it, which is right here. And the API, there's a couple ways to do it, but the way I'm using here is there's just a dictionary. Key in the dictionary is the name of the region. The object you get back is another abstraction just called iRegion. Ultimately this thing manifests itself in the shell as a content control. But what if the shell developer tomorrow decides, no, you know what, it'll work better for our app if we make that a tab control. Module developer should be insulated from that. It just knows there's a chunk of real estate it can plug a view in. It's up to the shell developer to decide what the navigation modes are to get to that content. So we just get back an abstraction here called a region through an interface, so it can be easily swapped for unit testing and so forth. And on that region, we just say, add my view. Okay, why do we need a separate activate call here? Well, it depends on what that container is out in the shell as to what activate really means, or when should my view actually be shown. If it's a toolbar, they all get shown as soon as they're added to it. If it is a tab control, just because I added a new tab to the tab control doesn't necessarily mean I want that to be the foreground tab. So it's really up to, again, the shell developer and what container control they put you in as to what does it mean to add versus activate. So we separate that out into two discrete steps. And even for the content control, if you know the way those work in WPF and Silverlight, content control can have one child piece of content, a UI element. So what does it mean to add multiple views to a content control? Basically, the region takes care of that. The pattern that we implemented here, the paradigm, is a deck of cards. So the region itself can basically buffer up multiple view implementations. And when you say activate, it sets the content property, that single content property, to be the currently active view. But you can actually add, say, think about Outlook with a calendar view and a contacts view and an inbox view. You could just add all those to the content control that is that portion of Outlook. And then you activate each one, and it just swaps out the content property so it gets rendered by WPF. Okay, so that's the simplest form of a module. And the part of the Bootstrapper here that's loading it up is just because we say add module, the service under the covers in Prism takes care of, in that point of the workflow, says, okay, that was identified as something I should load up, construct it through the container, call initialize on it, and it can do whatever it was designed to do. So that's basically the simplest possible architecture there. And obviously that's much more complicated than window 1 automatically created by WPF to show a button. But the point here is that it's setting up a good, clean separation of concerns architecture, loosely coupled pieces of functionality in your app, that as this grows from a single view with a single button on it to an application with 24 views in it, now you have a good way to partition out the work. So you see our view just kind of dynamically plugs into the shell. The end user shouldn't know or care that this is how you're building your app. It's just a single app to them at runtime, but it's a dynamic composition of pieces of functionality. Okay, let's jump over to the slides for a moment, talk about the 2 remaining features, and then I'll show you a slightly more complicated sample that uses those. Any questions on regions or modules before I move on?
Once you try to add 2 modules to the same region.
I couldn't quite hear that.
Once you get trying to add 2 modules to the same region, would that be like a design time, runtime error, or would that actually be a code compiler?
So the question was, what happens if you try to add 2 modules to the same region? First, let me be nitpicky and say you don't add modules to regions, you add views to regions. So a module might load up and construct 10 different views and could add all 10 views to a single region, or it could add a single view to a region that another module added a view to. It's up to the region to sort that out or really the underlying container control as to what happens there. The design of Prism is that it's always safe regardless of what the underlying container control is, and that's where those region mappings come in. We're in that workflow I talked about that I said mostly you don't have to worry about that. Prism has pre-built implementations for content control, items control, and selector, which is a refinement of items control, which are the base classes for pretty much 100% of the kinds of controls you would plug content into in most WPF apps right now. Like I said, the only place that you might actually break something is if someone writes their own custom form of control that contains content that doesn't derive from one of those. Then you would have to provide a corresponding region mapping, region adapters, they're called under the covers, that says when a piece of content is added, what do I do with it on the corresponding controls API to actually show or add it logically to that view. But with the pre-built implementations, content control, like I said, does a deck metaphor. So if you want to put 4,000 cards in your deck and activate them one at a time, it's just fine. If it's a items control, it's just adding new items to the collection, and when you activate it, it's making that item the current item. So whatever that items control is, could be a tab control, a list box, a list view, a data grid. Those are items control derived things. They also happen to be selector derived things, so there's the initial notion of selection it also supports. Does that kind of answer that question? Okay. So you're kind of covered with the out-of-the-box code. You can add all the views you want. It's more about what you activate when as to what shows up when. Yes, sir?
Just a question about changing between views. I'm wondering if you wanted to have some consistent visual effect, like a little slide in, slide out. Would you maybe add that to your region?
Yeah, exactly. Either the region or really in the mechanisms. So the question was if you wanted a custom animation or a custom effect that when the view is presented, think about the slide out panels of Visual Studio, basically. If you wanted a slide out panel, how would you go about implementing that? How does that relate to Prism? That's really more of the shell's responsibility, or to be more precise, it's whoever has the region. Okay, I didn't mention this because generally I recommend don't use it, but the region feature is kind of n-level deep. So you could have the shell define a region, have a module load up and plug a view into that region. That view could have a region, and module B could load up and plug a view into that region. That view could have a region, and so on and so on and so on. So it's n-deep regions supported by the framework. Trying to manage that at runtime, it's just way too much magic. It's hard, you get this, this map is just showing up magically in the middle of my application. Who's contributing it? Who defined the region? Where, it just gets too hard to manage. So generally, I try to restrict. I only define regions at the shell level. I'm perfectly fine defining what we would call a composite view, which is like a complicated view composed statically of multiple child views that are typically user controls. And each one of those can be, well factored in, have its own separate view model, and so on. So in terms of, getting back to your question though, how would that manifest itself? In the shell, I would define a region just like before. Its container would happen to be, a content control possibly that is cited within a pane, some sort of slide out pane that I define through the other presentation mechanisms of WPF or Silverlight. So, that information is more about the container itself, which itself may or may not be the region. It could just be the parent of the region on which you apply an animation when it gets activated. And so typically it would have to have some sort of way of knowing when it's activated, and there's various ways to do that depending on what that containing control is. But mostly it's out of Prism's hands. That's just up to the shell developer to implement those effects. Okay. Commands, let me jump to that. Like I mentioned before, command pattern been around since Gang of 4, possibly before that, at least well documented in Gang of 4 design patterns book. It basically says that there's some abstract invoker out there that says something needs to happen. On the far end, there's one-to-many receivers, as the pattern documents, that can react to that command and make something happen. There is generally the notion when you're talking about the command pattern that it is action-reaction. So something invokes, there is an expectation that something will react to that. The distinction there is if we'll get to events. With events, it's supposed to be pure fire and forget, right? From an invoker's perspective, it just says something happened. There's not necessarily an expectation that anyone's actually listening or going to do anything about it. So it's very similar to events here. You've got decoupling in the middle here that says receivers can come along and they can kind of come and go, and the invoker doesn't have to know who the receiver is. So there's a lot of overlap between commands and pub/sub events, which we'll look at next. Specifically in a UI context, there is also usually the expectation that a command is invoked by a user interface control, such as a toolbar button or a menu item. And there's also enablement and disablement of that piece of UI that you want to happen automatically. So if it is not appropriate based on who the receiver is to invoke the save command because nothing is dirty, then that command should be disabled and the corresponding piece of UI should be disabled. And I shouldn't have to write code every time to do the manual enablement, disablement of the UI to make that happen. So in WPF, we have a built-in infrastructure called routed commands that already do most of this basically. The problem with the built-in thing, it's very good for certain scenarios. In a few lines of code, you can put a text box in your UI. You can put a button somewhere that says, I raise the cut command. And there's already built-in implementation that will cut the content out of the text box, put it on the clipboard. You can paste it back in and so on. So a nice declarative model. The downside to the WPF stuff is it's totally coupled to the UI definition. You know, if I had to summarize in a nutshell, what is Prism all about? It's to decouple everything from the view definition itself. You know, all of the logic code should have no implicit knowledge of what UI it's being hooked up to, ideally. So basically the design of routed commands goes directly in the face of what Prism is supposed to be doing for you. A couple other things. There is some tie-in, some very confusing tie-in I wrote about in an article in MSDN Magazine in September 2008 about how focus interplays with routed commands. And there's a lot of misconceptions out there that I had to blog about later because the tech review I got from the WPF product team came in 2 days before we went to print, and they went, yeah, you didn't quite get it right. And basically I had done all kinds of experimentation, convinced myself with demos, yes, this is exactly how it works. Like many other people I had read about or read from that said, yeah, this is how it works. Turned out we were all wrong. So I did a subsequent blog post, July timeframe, I think, of 2008, that described this. But there is a confusing tie to what is the focused element in the UI. I don't want my logic to know or care what the focused element is in the UI. I just know I have some action code, some logic I need to invoke because something happened. Who has the focus, whether it has the focus, that shouldn't matter to me at all. But where you hook things up with the built-in routed commands does depend on focus sometimes. And the sometimes is the hard part to explain. The other thing is, in the routed command infrastructure, there's facilities there to have multiple command handlers, multiple receivers, if you will, in the pattern hooked up. But the commanding infrastructure of WPF by default will only invoke the first one it finds. So if you have a situation where you have something like a tab control with multiple orders open, each one of those orders is using UI separation patterns, so its save logic is right behind it in a view model or something. Basically, if you have a save all button up in the toolbar button with WPF routed commands, there's not any kind of clean way to have each one of those individual pieces of logic code invoke save, 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 and let them be responsible for their own saving. You basically have to have centralized knowledge, usually all the way up at the window level, to get that done, which is exactly what you're trying not to do in a composite app. So bottom line, WPF routed commands are not evil, they're just not sufficient for a composite. So we needed something else, and we implemented it in the commands that come with Cal. Basically, there's two of them. They are based on the iCommand interface. So this would be the part where I should say, what about Silverlight? They don't have commands. They don't have routed commands. They do actually have, luckily, an iCommand interface definition. No implementations of it anywhere, but luckily they define the same interface that WPF did. So they have kind of the minimum definition to be able to hook commands up in a similar way in Silverlight. Maybe future versions of Silverlight will actually get some of the same infrastructure. In the meantime, we basically leveraged, or I should give due credit, I wasn't involved at this point. They leveraged the fact that we have this attached property trick I already mentioned, where you can basically just set a property on any given element in a piece of XAML in Silverlight and or WPF, and the setting of that property can invoke a chunk of behavior that you define anywhere. So what that chunk of behavior can do is behind the scenes wire up a command handler basically in the same way that the built-in commands in WPF do. So syntactically it looks exactly like what you would do in WPF. It's just not a pre-built property on the object. On buttons and menu items and stuff in WPF, you have a command property that you set. On any other object, even in WPF, but also in Silverlight, you just define a custom attached property. So you say myCommands.command equals instead of just command equals. Looks exactly the same the way you hook it up, same capabilities. Behind the scenes, you just have to do a little implement some glue code behind the scenes so that when that property is set in the XAML, a little chunk of code gets hooked up that says here's where the command handler is, and you can do that in a loosely coupled way as well. So it's all based on the iCommand interface in WPF and in Silverlight. And you can have multiple targets, you can be completely independent of the focus, and you can have the handling logic completely decoupled from the visual tree. Basically, you got two command types that we contribute. One is called delegate command. It's based on delegates under the covers to point to the chunk of logic that's going to be invoked. And you can wire it up typically through data binding so that it's loosely coupled from the place in the view where it gets hooked up. The other one's called composite command, and it's more for these submit all, save all kind of scenarios where you want the invoker to be far away from the code that actually gets invoked. So it's got an API where you can register a child command basically, and really all it is just a collection of child commands that gets invoked one at a time when the top level command is invoked. There's also a part of that I mentioned, which is the enablement disablement. Part of the API of iCommand is to say can execute, call can execute on the command, and have it decide am I enabled or disabled. And so basically what this thing does is it polls each of its child commands. The logic that we chose in composite command, you have the source code. If you don't like this logic, you can just replace it. Basically it polls and it says if any one of my child commands says no to can execute, then the overall command can't execute. But you could go change that and make it 2 out of 3, random draw, pick your strategy up here in terms of the way you want to decide can execute. But ultimately when you call execute, it just loops through its child commands and calls execute on those. The other thing we'll look at here in the sample is pub/sub events. Basically anytime you have pub/sub events, I don't really have a diagram here, well sort of. Anytime you have pub/sub events, you want loose coupling between the publisher and subscriber. And that basically means you need some kind of middleman that they both take the dependency on instead of taking dependencies on each other. So the event aggregator service, or more specifically the event objects that get registered inside that event aggregator, take the role of a middleman here. And basically you have a shared dependency on an event type, which I'll show you is very easy to define. There's a base class you just inherit from, and all the work's already done for you. So this one says I subscribe for events, say it's a stock price changed event. This one says I publish a stock price changed event that Microsoft is now at $30 or whatever is reasonable these days. And basically they don't have to know anything about each other, but they can have loosely coupled communications between each one. Some of the buildup here is just pointing out we have .NET events. There are also routed events in WPF and Silverlight. Why aren't those good enough? A lot of the same reasons. Routed events are directly coupled to the UI. They're really for element-to-element communications in the visual tree. This is for object-to-object communications behind the scenes of your visual tree, typically nothing to do with the visual tree. In fact, you can use this feature in Windows Forms. I did an implementation of that a little while back. You could use this in a Windows service that has nothing to do with UI whatsoever. But it is a in-process pub/sub model for object-to-object communications in a loosely coupled way. What's it look like in code? Let's get to that quickly because we're almost out of time. This solution is a slightly more complicated version. not too complicated, but let me run it so you can see the functionality. Simple little concept of an appointment manager. You have appointment objects that you can define for things on your calendar. In this case, we have a grid-based presentation of these, but conceptually you could have a month view, a week view, that kind of thing. We can right-click on one of these and say edit through a command. So a context menu item there fires a command, and the command handler in this case is in a completely separate module than the one that loaded up that view that's up at the top. That command handler says, okay, what do I do when that command gets fired? I present an editor for that appointment item in a tab view down here. So I can edit multiple appointment items at a time and go in here and change them. In the individual view, you can see we have commanding going on at this level as well. So one command caused the views to be presented. Another command handles save and cancel logic. The save logic says if the object's not dirty, save should not be enabled. As soon as I make it dirty, save gets enabled. And it also happens to, if I make this bigger up here, through the magic of WPF data binding, the object is live. So I also have some logic in there that if I cancel, it will undo the change, basically back out the change, not transactionally or anything, but just by remodifying the object. So for this one, save's disabled because it hasn't been modified. Okay, so that's a common scenario where you would use commanding and some of the aspects of it. And the place where the eventing comes in this app is when I click on an item up here, that view doesn't know or care if anyone out there cares that something was selected, but it suspects someone might care. So it can just fire an event and say, an appointment item was selected, and here is the appointment item that was selected. And someone else can do whatever they want about it. Over here in the module that's loading up these views, there's a controller that spans the multiple views being presented. It can subscribe to that and decide to activate the corresponding edit view if it is presented. If it's not presented because it was dismissed, it can do nothing about it. So I can select it all I want up here, nothing happens. But if it is presented and I click on it up here, it gets brought to the foreground down here just by activating the view is the actual functionality there. Okay, so what do the commands and events look like under the covers? The commands are a slightly more complicated part, and we don't have a whole lot of time for that, so let me just show you quickly. In the editor, the simplest ones are the save and edit one. You've got a view definition here. Behind the scenes, you've got a view model is where the logic resides. View model pattern is a standard pattern most people are favoring in WPF and Silverlight to basically separate out the kinds of things you would have dumped in the code behind before, separate it out into this thing called a view model, kind of like a presenter, kind of like a controller, just specific to the context of the way you do data binding in WPF and Silverlight. So here you can see we have an edit view defined that had the text boxes and so on, and was being plugged into a region that was a tab. If we can go to the designer here, you'll see it looks just like what was plugging in down below. And we have a corresponding view model, which is where the logic for that thing resides. If we look in the code behind for the view, this is what you want in your code behind in a view model-based world. Absolutely no logic in a perfect world. Sometimes you might have to put some spanning logic where an event fires in the UI, and then you kind of hand it off to the view model. But there's even ways to address that through something called attached behaviors, which are based on the attached property trick that I mentioned before. So in our view model here, all the gory details of how do we take care of dirty state of the underlying appointment object, how do we handle the save and cancel command, how do we say what our header is for when we're presented in a tab control. All that logic is encapsulated back here in a way that is not coupled in any way to what specific view this thing is tacked onto. So it's much more easy to unit test this thing because it's really just a bunch of functions and some state associated with those functions. In terms of the commands we're looking at here, you can see that, well, let's start at the view level. These save and cancel buttons under the covers are doing standard WPF commanding. They just say on the command property, I point to a iCommand object. Don't know what the actual type of that object is, we just know it implements iCommand. And the way we get to it in this case, when you're in a view model-based world, is you typically just bind to a property that's exposed by your view model. In a view model-based world, your data context for the entire view is the view model instance itself. So you always have this one-to-one correspondence between view instance and view model instance, except they don't know anything about each other. They're magically tied together through the data context and data bindings in WPF. All it really knows about it is there's some object out there that hopefully implements a property called cancel command, and the type of that property is an I command. If it's not out there, the binding mechanisms of WPF and Silverlight are forgiving. They just silently do nothing. And so basically our button would be disabled and wouldn't be usable, which is not necessarily good for shipping code, but in terms of development, you're not constantly dealing with exceptions being thrown as you're getting things hooked up. Likewise with the save command. And so in the view model, on those things they're pointing to, these are just instances of that delegate command class I talked about. The reason it's a generic, in this case, because it's close by, this whole view is all about managing a single appointment item. So we don't actually have to pass anything to it. The view model itself maintains the state that we're trying to save or cancel on. So we don't have to explicitly pass something here. But when we fired that edit command back up here in the list, we can see in when we fire this command, we're pointing to a command object. I'll get into that. But we specify a command parameter to say which specific appointment item are we actually trying to edit. So you can carry along a strongly typed argument to these commands. And that's why there is a type argument here that you can supply to a strongly typed thing. Populating this thing, you just construct the delegate command and point to its execute method and possibly to a enablement method. That basically needs to return a Boolean to say yes or no, should I be disabled at any given point in time. And the cancel command is always enabled, so you don't have to supply that. You just supply the method that gets executed when it cancels. And the specific logic on these, if we look down here, can save is just checking our dirty flag, which is maintained by the rest of the code. Save here is simulating saving off the appointment item up here and telling its controller, which is back here in the module, or is it editing controller? This is from a patterns perspective. The closest matching pattern is called application controller. Really, you could sort of redefine it as module controller in this case. It's a controller class that takes care of all the view presentation for that module, since that module is independent of all the other modules. But if you weren't doing the full composites, you would typically have one of these that says, when do I present what view in the entire application? Okay, the other composite command that's hooked up here as far as the list view is concerned, this one is hooked up a little bit different way. Instead of a binding, choosing a static reference to basically a global. And that's typically how you hook these up. The declaration of this thing, WPF, or rather XAML, XML namespace reference here, appointments command class, edit appointment command object. That's out here in a shared library, categorized under commands. And we can see that it's just a public static class containing a public static instance of a composite command. This is the way WPF always defines routed commands, is you declare these statics everywhere, and there are these big hairy globals that you can get to anywhere in the app. Kind of a downside because there's lots of ways you can leak memory and do nasty things with these. I wrote a blog post about this recently you can read if you want to check out my blog. But this is the standard way to hook them up. Point to them through a static reference, and then from anywhere in the app, such as down inside of a module, like in my controller here, I can have a target child command, which is typically a delegate command, and this one you can see takes a strongly typed argument. That's the appointment we're going to edit. And in the handler for that gets invoked, we can do whatever is appropriate. And in this case, it basically says, am I already presenting an editor? If not, add one to the that region. And if I am already presenting it, just activate it to make sure it comes to the foreground. So that's basically it on commands. And then very quickly on events, which are even easier to understand. We saw that the source of an event was clicking on an item in the list view. Go look at what does that look like. It's actually all controlled by the view model itself. The view model gets notified in this case. I didn't use an attached behavior, which would make it even cleaner. I do have to do a delegation through the code behind of the view. So the view handles basically a selection event on the list view, and then it just hands it off by firing an event, which the view model subscribes to. Says, I don't know what to do about this. I don't want to put the actual handling code here because I need to test handling code. I'll just fire the event and let the view model handle it. And in the view model, We said it's all about this event aggregator as a middleman, or a container for middlemen. You do have to get that from somewhere. It's another one of these singletons like the region manager. So we just put it on our constructor and say, I don't know where it comes from, container, you figure it out and give it to me. At the point where you want to fire the command, you have to use it. And it's basically one line of code to publish, one line of code to subscribe. It's a composite line, so it's really 2 calls. You go out to the event aggregator and you say, give me a typed event that represents some specific action or thing that goes on in my application. Once you have that event object, you just call publish on it and pass a strongly typed argument. So that payload that you pass is, the relevant information that the subscriber is going to need to know about to do something about the event. In this case, it is our selected appointment item that came off our selector control, which is a list view in this case. What's this event type? This is all you need to do to declare an event type. You derive from a base class that's provided in Prism, and you say what is that payload type that you're going to pass when you fire the event. So all the guts of how do you fire the event, who are the subscribers, how do I dispatch it from a thread perspective, because the other features that are in these composite events that's kind of nice is thread dispatching. This is all a UI context. Both Silverlight and WPF have the same notion that don't modify the UI unless you're on the UI thread. If you don't have someone do that automatically for you, you got to do dispatcher.current.invoke, all this garbage. We've encapsulated that for you down in the composite event here. The other thing the composite events support is basically weak references. One of the easiest ways to have the appearance of leaking memory in a .NET application, take a subscription on an object, which basically holds on to a reference to that object, and then forget to unsubscribe. Pop a dialog, subscribe, just dismiss it. Pop a dialog, subscribe, just dismiss it. You're creating objects and you think you're letting them go, but the subscriptions are still holding on to them, so your memory grows and grows and grows and grows. Good way to combat that is the weak reference object in .NET. Basically it's kind of like a pointer in C++. It's 2 levels of indirection to the object, and the weak reference wrapping object, basically the way it holds on to its reference, the .NET runtime is aware of, and when it does its reference counting basically to figure out whether it can garbage collect an object, it does not take into consideration weak references. So basically your subscription can say, if it's out there, notify it. If garbage collection comes along, pretend I'm not here. If no one else is referring to it, you can go ahead and garbage collect it. So that's what we do by default under the covers. You don't like that when you subscribe, you can just say, don't do that. Keep the reference around. Third thing it does is filtering. It's got a nice lambda-based expression way of specifying a filter criteria based on the payload that comes in. So if it's a stock price changed event, you can just say a simple lambda expression, or just through a delegate point to a method that says, if the stock price is Microsoft and the price is greater than 30, then I want to be notified so I can do some stock trading based on that. So very simple ways to do those things on the subscribing side. But this is still the publishing side, wherever we were here in the view model. We just say .publish with the argument, and it's up to the subscriber to figure out how to deal with it. Subscriber in this case is also the controller. So he similarly takes a dependency on the event aggregator, and he can do his work with it immediately on construction, because all he's going to do is subscribe and point to a handling method. Simplest form of that, just point to a method that has the right signature, which is basically a void return type because it's fire and forget, and takes in the strongly typed payload and can do what it wants with it. The more complicated forms that I mentioned are the overloads. I can say true if I want to not use a weak reference. I can say thread option dot either UI thread, publisher thread, the one who's making the call, or background thread, thread from the thread pool basically. So you have 3 options there for dispatching depending on the scenario. And then the filter, you have to specify actually all of them. So we could say false for go ahead and use weak references, thread option, again, dot, let's say UI thread, and then filter would be you use a lambda expression. We could say item, where item dot date and time greater than datetime.now or something, which is kind of hard to do. Well, not for an appointment. Could be a future appointment. But basically you use a lambda expression there as the most concise way to specify your filter criteria. And that's basically it on event pub sub. one line to subscribe, one line to publish, other than just the dependency injection to get to that event aggregator. Very clean, easy to use model. And that is basically it on Prism. So kind of fast and furious. Don't have to use all of those. Pick one of them. I almost always use delegate command in any WPF app I use. It's a nice clean model that I can data bind to, hook up the subscribing method in my view model. So pretty much any WPF app I use, I'm going to take a reference to Prism, but I may only use commands for a simple app, may use just pub/sub, may use just those two for loosely coupled comms, but not do any of this magic view plugging into shell, may not define things in separate modules, could statically compose my application in a traditional sense. So it's basically use any of those you want. Don't really have time to go through all the different separated presentation patterns, but just realize under the covers in Cal, lots of other patterns going on. Patterns and practices, that is their first name. So under the covers, we're using adapter, command. Those are from Gang of 4, service locator, and version of control. Separated presentation is kind of a meta pattern for model view controller, model view presenter, model view model. This shows model view presenter. Plugin, separated interface, event aggregator, these are all formally documented patterns that we're just providing a pre-built implementation to do in WPF or Silverlight. Lots of individual resources on this. I've done several podcasts. Other people have done podcasts, articles in MSDN magazine, Code magazine, lots of things you can read up on this stuff if you want follow-up. Or just ping me by email. I can obviously babble at length about this stuff. Any questions before we wrap up? Yes?
How would you pitch Prism to somebody or a company that's already using NVVM and, say, Unity? What would you say is the benefits of using Prism, and perhaps what's the downsides of using Prism?
Okay, great question. So basically the question was, if a company is already using MVVM, or at least a separated presentation pattern to make it more general, they're already using a container, so they have some loose coupling provided by that. What does Prism really provide an added value from that? There is no form of loosely coupled communications in what you just described. So how do you loosely coupled hook up the view to the view model to do commanding, for one thing? There's not really a pre-built way to do that. So you'll find articles like there's a great article on MVVM by Josh Smith in MSDN magazine. Look at what he did. He created this thing called relay command, put relay command side by side with delegate command. Guess what? They're basically the same thing, just slightly different APIs to them. So you would have to pre-build your own replacement for what delegate command does for you anyway. So basically it's just, that's already built for you. You just take a reference and use it. And you have composite command as a different kind of pattern for using even sort of more distant commands, typically, unfortunately, through a static object. But you could also just register your composite command with the container, locate it out of the container, and hook them up that way. So it doesn't have to be through a global. Other things, pub/sub, another form of loosely coupled events. There's no kind of pre-built thing. So my favorite features are definitely the loosely coupled communications. The view composition story, sometimes I don't like that one bit because it's too much magic. If it's working right, it's cool. If it's not working right, it's just more magic I have to debug. Same could be said about containers in general, but this is just another form of dynamic plugin thing you have to sort of get correct and sort out. So I can take or leave that, but some people really like that if they can basically just deploy a whole new module and presto, new functionality shows up in the UI in the right place, with no change to the existing code. So that would be, a value proposition you could present depending on the scenario, especially for sort of third-party contributed functionality in an application. If some third party wanted to provide a plugin that provided you a map view of all your customers with density rendering of those customers, it would be very easy to do that with the regions feature. You'd have to write your own sort of custom plugin UI architecture to do that otherwise. And the module loading, that could be provided kind of through the container, through MEF. There's lots of ways to get that done. So that's not a strong thing on its own unless you're already using Prism for other reasons.
Are there any instances where you'd say it's best not to use Prism and best to go, apart from smaller applications?
Yeah. So the question is there anywhere I would say don't use Prism? The main criteria in my mind is if it's a fairly simple app, A rough threshold in my own head that's kind of lingering back there is if it's less than a dozen major views that I'm going to be presenting, I can probably get by without Prism. But like I said, even there, I would probably personally still use Prism for the communications between views to keep those loosely coupled from one another. Might not do any separate modules, might not do any any dynamic plugging of those views, but I'm almost always going to use delegate command and the pub sub model for communications. Just so you don't get that, I was doing this about user controls earlier. How does this user control talk to this user control? Otherwise, you got to take object references or take event, .NET event subscriptions, start tightly coupling those things. If you have pub sub, just fire an event over here, subscribe over here. They don't have to know about one another. So I really like that model. Anything else? Yes?
Is there any plans for a forms-based implementation of that?
Windows Forms? Go out to my blog about, I think it was August 2008. And basically what I did is, I have not updated this for Prism 2, so I need to do that someday. But basically I took Prism 1 and backed out some of the dumb things we did. I was equally guilty about this. Parts of Prism should be completely decoupled from WPF. Modularity has nothing to do with WPF. PubSub events has nothing to do with WPF. The way that we plug in and do regions fully leverages WPF, so you can't easily do that in Windows Forms, but what I did in my implementation was I just leveraged the container and basically resolved container controls out of the container and said add, controls.add to that thing to plug in my views. So you can simulate regions just using a container. So basically I have an implementation there that does regions, events, and modularity. But since there's no infrastructure for commands in Windows Forms and there's no magic tricks like attached properties, there's not really any way to get a decent commanding story there.
Just say at the beginning that Prism 2 is not, you can't use it as Silverlight 3 at the moment?
At the moment it's not, formally released. It's not, like I mentioned, I forget who it is. If you Google, Silverlight 3 Prism kind of thing, there's someone out there that had, at least one person, I think several, have written their own just minor modifications to the code to make it compatible with Silverlight 3. But as I mentioned, also currently the product team, or the team at is working on a version that's compatible with Silverlight 3 that should be out very soon.
Do you have any idea on the time frame for that?
As I last talked to them, I don't specifically, but as I last talked to them, the impression was, probably less than 2 months. I would, if I were to venture a guess. It's imminent to a certain degree. Yes.
When you say you can use the attached property to replace the events, what are you exactly doing?
Actually, it's attached properties to simulate commands in Silverlight. So even though Silverlight has a definition for iCommand interface, the other side of it in WPF, that command property I showed on buttons, menu items, and so on, that property is because those objects implement a separate interface called iCommand source. That does not exist in Silverlight, nor does any pre-built implementation of iCommand. So the way you have to simulate that in Silverlight is you use these things called attached properties. When you set the attached property, the code that supports that attached property, when it sees that it's being set, it's got a little chunk of code that can say, okay, I'm being set on a particular object. It knows the element it's being set on, and it knows the value it's being set to. So in the same way I can say binding save command in that one demo, I can say binding save command is my value I'm being set to. And in the code behind, or the supporting code for that attached property, I can grab that value. I can grab the object I'm being set on, and from that object I'm being set on, I can say, is that a selector, for example? And so if so, I can say, if it raises the selection changed event, I'm going to take the binding that I was given that points to a command and just go invoke that command. And basically now I have a selection command, even though there's no built-in implementation of selection command in WPF or Silverlight.
The other question is, when you show me the code behind for one of your form, you have an event handler, and you said you can further link that code by using the attached property.
Yeah, so that's where I was saying for this specific case, where in this list view, ultimately what I'm trying to react to here is that on this list view, a selection changed event fires because I clicked on an item. that particular control does not have a selection command that I can just hook up to and bind to. So that's the specific case I was just referring to. Is the slick way of doing that is to define an attached property that's called selection command. And when that property is set, I see who's it being set on, subscribe to the selection changed event behind the scenes, and then call the bound command object when it actually fires. That's the slick way to do it. The quick and dirty way to do it is just to say in the code behind for the view, like I'm doing here, you know, in the view code itself rather, I have a handler for the selection change routed event. I put the event handler in the code behind, which is the only place you can put it in WPF. But then somehow I don't want to put the real handling logic here. I just want to say, okay, I got to do this kind of dirty trick to do it because I'm too lazy to go do the attached property for this demo. But I want to, as quickly as possible, get it dispatched over to where my real logic lives, which is in my view model in this case. So to do this, I had to provide some coupling between the view model and the view. If we look closely up here, this view model takes the dependency on the view. And worse yet, I'm doing it on the concrete type of the view. Generally, if you're going to do this, sometimes you have to. At a minimum, you want to do it, you want to define an interface and abstract yourself from the concrete type so that you can swap out different views that all implement that interface. But for quick and dirty demo purposes, I took a direct coupling here so that I could do this right here, subscribe to a event that is raised by the view. And when that event fires, now I can invoke the real logic of handling selection. But a much cleaner way, just go, do a search on selection changed, attached behavior, and you'll find blog posts that show how to implement this. Anyone else? All right, thanks for your attention. Back over to Adam. And off to our
Before you go, I've got a task for you. Go to tv.ssw.com and subscribe to our newsletter. You'll be informed of all upcoming videos. In addition, if you're super keen, I'm all about inspecting and adapting. So send me an email or send me a tweet @Adam Kogan. Cheers.